So, very good afternoon to all of you. Today's topic of the talk is on UAV remote sensing. So, I'll give you a brief overview about what is the advantage of using UAV remote sensing, what are the basic components, or how many types of drones or UAVs are there, and what are the potential applications where they can be used. So, with this, we'll start the lecture, right? So, as you all are aware and have been studying in the module also from the first lecture onwards on the fundamentals of remote sensing. So, remote sensing, as you all know, refers to a technique of capturing information at a distance, that is from a remote place, by use of certain specific instruments which are placed on a platform. So traditionally, remote sensing has been associated with platforms like aircrafts or satellites, which you have been listening to or learning about it from the beginning of the module, right? And the advantage of a satellite-based platform, as you all know, it provides a synoptic coverage and with a range of spectral capabilities. You can acquire data from visible to infrared regions to microwave regions. So you have a range of sensors, sensors equipped with a range of spectral capabilities. But the major drawback with the satellite-based platforms being the limitation to the spatial resolution. So we do have 50 centimeter or 30 centimeter data sets from satellite-based platform, but they have a limitation of coverage, plus the cost of these data is quite high. Then second aspect is the acquisition time. So generally, you will get this data bi-weekly or even with the, if you get a data with very high frequency, that is every day, then the resolutions are poorer. If you want a very high resolution data sets, then the acquisition, your temporal resolution is poorer. And this is one aspect. Then in contrast to it, the aircrafts which is there, the aircrafts which provide you better spatial resolution around 7 centimeters or so than the satellite compared to a satellite-based platforms, but they are expensive and the operations are susceptible to weather and cloud conditions because you cannot fly them as and when you want, so it needs to be a proper planning. And if there is a cloudy conditions, weather conditions are not bad, then you need to rework or replan your flights. And then since it's a manned mission, a pilot is required to fly these aircrafts, even the cost of the data is much higher. Then another platform which is there also being used in remote sensing, that is the ground platform or ground serving instruments, which gives you a very, very high resolution data because you are taking it on the ground itself. The resolution of the data is very high, very precise, highly accurate data sets. But what are the main challenges in this ground-based platform is that they are labor intensive and time taking. They are also expensive and difficult to acquire data in inaccessible areas because you have to go by vehicle or by manually you have to trek by foot or by vehicle. So many of the areas which is inaccessible, it becomes difficult to acquire data in these cases. But these platforms are essential in the sense that they are used for calibration and validation of remote sensing data products which we derive from space, satellite or aircraft-based platforms. And in the recent past decades, if I say so, with the increasing developments and improvements in the sensor technologies, platform technologies, drone-based platforms have become a very, very important element in the field of remote sensing. Right, and drones play a role somewhere in between the satellite, aircraft, and the ground-based observations. So they provide you high-resolution data sets. Frequency of the data can also be, you can control the frequency as and when you want the data. You can collect the data. So image acquisition can be on demand. The resolution can be 1 centimeter or less than a centimeter level. I mean, generally 1 centimeter level per pixel can be the resolution. It is unaffected by cloud cover, as you can fly as low as below and acquire the data. It is safe and cost effective. But the major drawback being, we'll talk about the regulations. They have a smaller coverage. They also are susceptible to weather conditions. So drones, as I said, they are becoming popular nowadays in many remote sensing based applications or civilian applications. Earlier, they were primarily used for defense applications. So being the major advantage is possibility to fly everywhere, every time, flexibility in the sensors, whichever you want to install, which miniaturization of sensors is happening, though there is a limitation, but still you can install the sensors as per your requirement. The reduced cost is there compared to the aircraft. And another advantage is you can say they are filling the gap in terms of where you want to have very, very high resolution data sets. So from space, it is not available from space or ground-based platform. So in a way, we can say drones or UAVs play a key and a complementary role in remote sensing technology, especially for certain applications. In certain applications where they have a very key role to play is in the area of disaster management, where the time of data or the time of acquisition of information is crucial, and the information has to be obtained and disseminated as quickly as possible. So what happens is, if suppose a disaster is stuck in an area and there is no satellite pass on that day, so one can deploy the drone and collect information for both search and rescue operations, damage assessment, or other mitigation actions in those areas. So in that case, drones can immediately be deployed and the data can be obtained. So where the data is crucial, the time of the data is crucial, resolution is also very high, so you can deploy, UAVs come into handy. Another area where you can think, an agriculture sector where even government is promoting a lot of activities where drones are becoming useful is in the field of agriculture. We'll talk about it subsequently. Then another example where drones have a very effective role is in the mountainous or a hilly terrain. So in cases of the flat areas, satellite data, geometry is okay. But in case of hilly terrains where mountainous terrains are there, because of the satellite acquisition angle, satellite also acquires at a certain angle, and the sun elevation. So both together, because of the elevation, sun elevation angle and the satellite geometry. So the illumination geometry and the viewing geometry in a hilly terrain, some of the areas, they are under either the shadow regions or because of the mountainous topography, they are not acquired properly with proper resolution from the space-based platforms. So what happens is many of the areas in the mountainous regions where steep slopes are there, they are not captured with appropriate resolutions and the clarity. So in those areas, you cannot extract information effectively from a satellite-based platforms. So drones can offer, the flexibility or versatility of acquiring high resolution information in these missed out observations from the satellite platforms. Right? So in a nutshell, we can say they offer high versatility, flexibility as compared to the airborne or satellites, and they can operate rapidly without planned schedule. That's what I said, possibility to fly everywhere and every time. Right? Flexibility to install any kind of sensors, reduce cost as compared to the other platforms. You can fly at a very low altitude, hence it is you can avoid the cloud. It can fly below the cloud cover, so and unaffected by it, and collect very, very high resolution, spatial resolution images. However, there are limitations that of drones is that the volume of the data is quite large. Then it collects the data at a very, very relatively smaller area, and the rules are governed by the drone regulations of a country. So each and every country has its own drone regulations. So we have certain limitations also of the drone environment, because you can't collect data of a very large area. They have a very, the battery life, the span of the battery life is less, so they can fly at a very short distance, cover a smaller area, right? So there are challenges also with the drone-based platforms. Now, let's come down to what is a drone or a UAV, which is generally drone. It is known as the popular name, but it is unmanned aerial vehicle. So it's an aircraft without a pilot on board that has the ability to fly autonomously, but can also be controlled by a remote on the ground, which is controlled by the pilot, which is there flying the aircraft. So an unmanned aircraft system or a complete system consists of an unmanned aerial vehicle, a ground control station, pilot, virtual observer, and a launcher. So this is the UAV. And if I have all these accessories along with it, it becomes an unmanned aircraft system. So UAS is consisting of a complete set of the accessories which are there, which has a drone, a sensor, a ground control station, a pilot to operate this, either from ground then a launch observer, then a controller from the ground from which you can control it, and a launcher which is there in case if it is required. Not all the kinds of drones require a launcher. So this we already have just discussed about the advantages and limitations of a drone. Is it's lightweight, low cost, high temporal resolution, fly at variable altitudes, autonomous, can be used in a very high risk situations, and it gives you data as and when you require. Limitations are the flight time, the battery life, the area which it covers, it is governed by the drone regulations of a country. Then sensors are limited because they have to be lightweight, and the total maximum takeoff weight depending on that. So sensor capabilities are also limited, or the cost is high. Then the weight of the camera is also large, so you need a larger UAV, and small areas can be collected at a time. Now, drones are also classified, there are different criteria on which drones can be classified into different categories. So some of these criteria are the size, the flight time, size or the weight, the flight time, the camera capability, taking off and landing needs, the design type, or the altitude level. So we'll talk about the three major categories which is there, that is the weight and the size, the range, and the aerodynamic capability, that is the design type of the drones. Now, as per the Indian regulations, according to the weight and size, the drones are classified into 5 categories: nano, micro, mini, small, and large. So nano is the one which is less than 250 grams. Micro is in the range of 250 grams to less than 2 kgs. Beyond 2 kgs to 25 is mini. Then you have small from 25 to 150 kg, and large is more than 150 kg. So the nano drones which are there, they are just kind of an hobby drones. So these drones do not require permissions for flying. These are, if it is not there with the installed with a sensor, then you can fly it as a part of hobbying club without requiring any permissions from the DGCA, that is the Directorate of Civil Aviation. But the moment the sensors is installed, it is in the range of micro, mini, small, and large. You need appropriate permissions to fly these drones. So generally, if you talk about remote sensing platform, if you want to use it for remote sensing applications, the weight of the drone along with the sensors increases from, it is generally in the range of 2 to 25 kgs, that is in the mini range, and that requires permission to fly. Because most of the sensors which you will install on the drone, so along with the GPS and other instrumentation which will be there in the drone, so weight increases beyond 2 kgs. So generally it lies in this range. But if you only have an RGB camera without much of the other sensors onto it. Then you can also have drones with less than 2 kgs and collect the images with those also. Then based on the range, there are different categorizations like close range, short range, medium range. And this is also dependent on the endurance. Endurance is the time which is required, flying time. So close range is when the battery life is such that it cannot go beyond a certain distance, that is 10 to 30 kilometers. Short range is 30 to 70, medium is 70 to 200 kilometer range. So when the battery life is large, if it can fly to 45 minutes, I can go for a medium range drones. But if the battery life is very small, it is 20 minutes, 15 minutes, then these are generally in the category of the close range. So endurance time is less, then it's a close range. That again is interlinked with the weight of the drones. The nanos, the micros, they have a very small battery. So power of the battery is also less. So they are short range drones. The mini, small, generally the small category and the large category drones, which are heavyweight, have a better equipped powered battery, and they can fly in a medium or a long range endurance they can have. So these are all interlinked to each other. Then based on the aerodynamics, we have two categories. One is the fixed wing, and the other is the rotary or the multi-rotor drones. So fixed wing drones are just like your aircraft with, as you can see in this figure, it's an aircraft structure. So it has a fixed wing and it flies also like an aircraft. It needs a landing and a takeoff space. Multi-rotor is more like an helicopter kind of a thing, which it can take off and land from anywhere. So different applications or different models which is there if you talk about. So multi-rotors, if it is say, it is much easier to operate. They are cheaper as compared to fixed wing because even their battery life is less. So they have short flights, less than 30 minutes or 40 minutes maximum now with the upgradation into technology. And they can have a vertical takeoff and landing. Because of the shorter endurance, they have a low coverage area, and they comply with the aviation regulations, and they are very suitable for local mapping. Now, fixed wing drones, which needs experienced operators, is like an aircraft. They are slightly expensive because stability is more in the fixed wing, and it requires sufficient space for takeoff and landing. They have a longer endurance, longer flight time, so you can go up to an hour, and requires a specific permission to fly, and they are suitable. Since it has a longer endurance, you can fly it for a larger area and collect data at one go for a large area. In case of multi-rotor, if your area is large, you have to have a multiple flights. So one flight, you cover a small area, then bring it down, charge the battery, then go and collect another area, third area, fourth area. So in multiple flights you have to do, whereas in a fixed wing, since it has a larger endurance, you can cover it in a single flight. So based on these pros and cons, I can say fixed wing is the best when an extended flight time is required over a longer distance. And if a small area is to be mapped, then the multi-rotor, and multi-rotor also has an advantage that they can remain stationary at a place where fixed wings cannot stay stationary. So in some applications, if you require for communication purposes where the drone needs to be stationary at a point, the multi-rotors or the rotaries can stay there. And it is also useful for the rugged terrain. So if you have a mountainous terrain like this, so the multi-rotors can fly along the slope, whereas the fixed wings flies exactly vertical. So whereas rotaries can be tilted in any direction, and it can be collect the data along the slope also. So they are very useful in the rugged terrains or another thing is you don't have a landing space and a takeoff space. So they can take off and land at a point itself. Right, so these are some of the different categories of multi-rotors. You have 4 rotors, it's a quadcopters. If you have 8 rotors, it's a octocopter. If there are 6 rotors, you call it as a hexacopter. Single axle rotors are there, and these are the fixed wings which is available. And also nowadays we have a hybrid kind of drones, which looks like a fixed wing, but they can be landed and takeoff can be done with them. I mean, thrown up with the hand. So they don't need to be requiring a landing and launch space. So they can be, launched with the hand, thrown with the hand and launched. There are solar powered drones. So there are various categories of drones which have been now available in the market. And as it said, single rotor, vertical takeoff, landing, fixed wing, they require a certain space. But now with the hybrid now this is a hybrid drone which can be from the SenseFly, where you can simply launch it with hand itself. So the advantages you can see for both of them, there are different. So accuracy wise, stability wise, fixed wings are there, but quadcopters have an advantage in the other aspects, but they can fly in any kind of terrain conditions. Right. So these are also examples for better power. Battery, solar powered drones are also being manufactured, but these are still not completely operational. But yes, there are a lot of testing going on with the solar powered drones. So if you talk about the different components of a drone, you have a frame, then you have the flight control system, a battery, then the propellers are there, then the gimbals are there, the camera is there, and the ground control system. So if I talk about individually, you have a frame. Now this frame is made of different materials, which is coming up there with plastics and other, but much more sturdy. So it should have a sufficient strength to hold the propeller momentum and additional weight for motors and cameras. So it should be very sturdy enough. Sturdy and less aerodynamic resistance. So this should be the property of the your frame. And then the main part is the flight controller. So this is basically the brain of the drone. Now the flight controller takes its input from the GPS module. Now GPS module is also there on the drone, which helps in navigation. It tells the location where the drone has to fly, where all the data has to be collected. So the flight controller takes the input from the GPS module, compass, and the other obstacle avoidance sensors, and the remote controller, and processes it to this information that is given to the speed controller to control the motors. So, I mean, this is, you can say, the heart or the brain of the complete brain of the entire drone system. Right? Then there are propellers. Now the propellers are responsible for lifting of the drones or the UAVs. The speed and the load lifting ability of a drone depends on the shape, size, and number of propellers. So if it is a quadcopter with 4 propeller and with 8, the 8 propeller one will have better weight lifting capability. So you can have a larger weight if you want. So your small category drones, if it is in the rotary ones, will have octocopter capability. I mean, with 8 propellers. So the long propellers also, long and short propellers. So the long propellers create a huge thrust to carry heavy loads at a low speed and less sensitive to change of speed and rotation. Shorter propeller sizes carry fewer loads, so that is weight carrying capacity is lesser. Right? Then this is a battery, a radio transmitter to control from the ground and control the drones from the ground, which is there. A radio receiver is there. You have a telemetry module, a camera, video transmitter, and a video receiver. So a GPS module, which I said, is also there, which uses the GPS systems to pinpoint the drone location. Right? Then drones also use few sensors on board it to measure its attitude parameters, like accelerometer is there, which measures acceleration in all axes. Gyroscopes measures the rate in all 3 axes, that is the roll, pitch, yaw part of it. Compass is there, which determines the heading. GPS, as I said, to navigate. Power module to supply power to the flight controller. Then optical floor is there for more accurate landing of the drones. Then there is another, nowadays all drones have this, is an obstacle avoidance sensor. Now this is basically for the safety feature, which is found in now most of the drones. Earlier it was not there, but now most of the drones have this feature for the safety of the drones. What it does, it scans the environments and detects any obstacle which is there along the route. So to avoid any collisions in real time and avoid obstacles in the flight path, any bird is there, anything is there, so it tries to move away. The moment it detects some object, it tries to move in the other direction. So there are various technologies which uses such as infrared, stereo vision sensors, ultrasonic sensors for detecting the obstacles in the path of the drone. Then ADBS is there to broadcast the position where the drone is currently placed, right? Then drones nowadays are also equipped with all kinds of sensors which can be there. You can develop your own sensors. Your cameras are already there, but beyond these cameras, you can develop sensors for measure the humidity, to measure pollution. So these modules can be developed and deployed onto the drones to measure these parameters. So in general, we have the electro-optical sensors, which is generally your RGB cameras, capture images. They can capture a still photograph or they can capture video images. And then we have the thermal cameras, which can capture the temperature variations. Then LiDARs are there, SAR is there, hyperspectral sensors are there. So we can have chemical detectors, synthetic aperture radars. So though these synthetic aperture radars and hyperspectral sensors, the weight of these sensors are still on a higher side, so you need a much heavier drones to carry these sensors. SAR is the most heaviest one, but even compared to your multispectral and optical sensors, hyperspectral is slightly on a higher side. But other sensors, RGB and the multispectral sensors, they are now few grams itself, few 100 grams, which can be placed on the drone and get good quality of data sets. Right? So these are other sensors which I said one can plan and install or develop and install is the barometric pressure sensors, your temperature pressure sensors, then any other pollution for monitoring the pollution. You can design your own sensors and place it on board the drones. These are few RGB cameras or the multispectral cameras which are available and can be placed on the drones, both the rotary as well as fixed wing drones. And that's very simple. As it says, the weight of this camera is just 560 grams, which is an RGB camera with a 24 megapixels. This is a multispectral camera which is having bands similar to mapping the ranges matching to Sentinel-2 and Landsat, which is a weight of 700 grams. Then this is a thermal sensor, which is 320 grams in the range of measuring the temperature in the range of 7.5 to 13 micro. Though it's a broadband, but it provides you temperature variations. Then the hyperspectral sensor, just a 600 gram, but then this 600 gram hyperspectral is only in the visible region. The moment you add the SWIR band, the weight of the hyperspectral sensors increases. So if you are measuring only in the visible region up to 1000 grams, then you get the hyperspectral sensor in the range of 700, 800 maximum grams sensors are there. For the multispectral, there are two ways of getting multispectral sensors. One is a modified multispectral sensor. A modified sensor is by using it doesn't give you instantly in multiple bands, multispectral bands, 5 bands, 4 bands. It's a 3-band camera and you apply a filter. So various filters are there. So at a time you get 3-band data. So if you are looking for red, green and near infrared, you apply a filter. So your blue band is left out. So if you want a 4-band data, first fly with RGB and then put a blue filter and get RGNIR. So with this multiple flights, you get the data, not in a single flight. The cost of these modified multispectral sensors are cheaper as compared to the actual multiband multispectral sensors, which have 7 to 8 or 10 bands at a time. It collects and it gives you the data in a single combination instead of a 3-band. So these are few multispectral sensors just listed from various companies. Some of them, there are many more available in the market. So you have from Altum DLS with different ranges. So most of them, they are now coming in the range of less than around 600 grams or less than 600 grams, and a good spatial resolution they can give. And they have bands of 5 to 8 bands. So in this case, you say they have a red edge band, which is very crucial for vegetation studies. So you have blue, green, red edge, near infrared. So multiple bands which are there. And there are cameras which offer 10 bands, which is matching to your Landsat or the Sentinel data sets. And one can compare or combine the two together. There are also cameras which offer you with directly the NDVI output. So they have two cameras and it processes it and gives you the NDVI value of in this region. And this is the RGB camera with 12 megapixels. Similarly, we have thermal sensors available in different ranges. So this is operating from 7, they are in the broader ranges, 7.5 to 13.5 micrometers, right? So a number of companies are coming up with different models. Some are calibrated, some are non-calibrated. So calibrated ones are slightly more costlier than the non-calibrated, but the cost is nowadays, they are becoming cheaper. So if you buy a non-calibrated cameras for the thermal sensors, then you have to do a lot of calibration before you actually extract the temperature from it. If it is calibrated, then directly it gives you the radiant temperature. So that process becomes faster, right? Now, the entire drone-based remote sensing, if I talk about the complete hardware and software, what is the requirement? You need an unmanned aerial, system or drone unmanned aerial where you have a drone with a sensor, with the ground control station, which has, a mobile or any monitor or a laptop from which you can see how your drone is moving, what are the areas it is covering. So this is a medium between you, the drone and you. So here you can use it for monitoring, then various sensors which can be installed on the drone. Then you need a software, which is essential for this, is a flight planning software, which is very crucial in the operation of a drone, because without this software, you cannot plan the data collection, or the data collection would not be with the right accuracy or requirement as per your need. Then you also need a GPS to georeference, because this data needs to be georeferenced. So there are two ways of georeferencing, direct and indirect. So many drones are also equipped with the high resolution, this RTK based GPS or PPK based GPS. So if they are equipped with that, then the cost of the drones is higher, but the data is directly georeferenced. If it is not, then you need a good DGPS system or an RTK system on ground, where you can collect these GPS ground control points along with the time when you are collecting the data from drones, and use these ground control points to georeference your data. Then you need a powerful workstation, because the volume of the data collected from these drones is very large. So you need a high-end workstation and to process this data sets along with a specific software. Right, so this is the complete flow of the collection and processing process. So you need to plan and upload the flight planning parameters, because as I said, flight planning parameter is very, very crucial, or you can say a mission planning software. This interface is always there whenever you buy a drone, or open source is also available, few of them. You have to interface it with your drone. But in general, whatever drone you buy, the mission planning software is a integral part of it. So in this flight planning parameters, what it does include? It includes identification and specification of takeoff and landing sites. Where do you want to collect the data? That is the area which you need to specify. The flying height at which you will fly the drone. Flying height, of course, is also governed by the flying permissions. Then direction and the speed of the drone, what will be the resolution and other aspects, the number of flight lines, what will be the overlap. So all these factors or parameters influence on the eventual images and the overall campaigning of your data collection, which is there. So flying height, you need to determine how high you would fly the UAVs or the drones. Now, this depends on the kind of spatial resolution of your requirement, what kind of resolution you are going to collect, and the focal length of the camera which you have installed on the drone itself. So you must be knowing it from the remote sensing also, that there is an inverse relationship between spatial resolution and the flying height. The higher the flying height, there will be a slightly lower spatial resolution. So if I can say, for example, the flying height is 145 meters, that will result in a spatial resolution of 5 centimeters from the drone platform. And if I increase the flying height to just double, 290 meters, then it may produce around 10 centimeters of the resolution of data sets. Right, so you need to decide what resolution of data you want. Accordingly, you will fix the flying height. Then overlap, how much overlap you want, 80%, what is the purpose? You want to generate a 3D from this, so your overlap should be appropriate, both forward and side laps. But if it is just for creating a mosaic, then accordingly to generate a seamless mosaic, you need maybe the overlap may be slightly less. So if you want to generate 3D models, height models, then sufficient overlap should be there, right? So if sufficient overlaps, that means 80 to 90%, and accordingly, your speed and everything would be governed. Then takeoff and landing sites must also be defined, and also the waypoints, where along, how will it collect the data? What will be the pattern of data collection from the drones? That also should be defined. That is the waypoint. So you need to define all this in the flight planning parameters, that is ground sampling distance, that is spatial resolution, what is the total area you want to collect, then what will be the speed, how much will be the overlap. All is part of this flight planning parameters. Right, and suppose you are using rotary based quadcopters for collection of flight, and your endurance is just 30 minutes flight and your area is large, so it also tells you how many flights you need to collect the whole area. So you have to plan accordingly. And when you plan for the takeoff and landing sites, just be ensured that there should not be any obstacles such as trees, power lines and all in the path. Otherwise, your drones might get damaged. And it is also important to consider the wind speed when selecting these sites, because UAV needs to take off and land against the wind. And this enables it to fly more stable in low speed stages. So wind speed, plays a very significant role. So it needs to be specified. And providing this information, which will enable a better estimation of the time required to fly an area, because it's easier to control, right? Then besides this flight parameters, then you fly. Then if you have an calibrated camera, it's okay. If it's not calibrated, then you need to do a camera calibration. Then using GCPs together, you can do a photogrammetric processing to extract 3D information, or any kind of that is height information extraction can be done, or you can generate an ortho image, and that ortho image can be used for any kind of feature extraction, extracting any important features which you see. So if you look at it, these are few sample images which have been collected from drones. So if you see, all images are not collected nadir. They are at any oblique angle. So this is an advantage, that I can have images collected. This is with a quadcopter, that in a hilly environment, I can collect it from any angle, and I can stitch them together to extract the kind of information like height or any other feature from these data sets, right? So these are few examples of drone images from different sensors. This is from an RGB camera. This is from our campus. This is with the multispectral camera. I haven't put all bands, but this is with the near infrared band, red edge band. This is with the thermal camera, which is there. This is an FCC with a multispectral camera. This is a single band images with the multispectral camera. This is an FCC image. So you can see all vegetation appears with red. And this is the thermal camera images, both taken during daytime and nighttime. So just a contrast. During daytime, the vegetation has a lower temperature as compared to the nighttime process. And then this is during the nighttime also data can be acquired from the drone platform. So this is what I said. You have to define the mission. That is from what are the locations where it will click and collect the photograph depending on the overlap requirement. So these are the waypoints along which path it will collect. So it will start from here. This is your takeoff site. It will go like this, collect like this, fly like this, collect data and land at this point. So all this needs to be defined in the mission planning software. So this is the different images from the infrared and the red band. We can calculate the NDVI of the images also. So this is there. So this is the complete workflow, as we said, for the photogrammetric workflow. So you have the GCPs, your tie points, measure them, then you can generate a 3D orthomosaic, and from these images, you can extract any kind of information which you want. You can do a 3D reconstruction, orthomosaic elevation model, and then extract the features of your interest. So the information which can be derived from an UAV this is the raw images, stereo overlapping images. You can generate the relief map, the 3D perspectives you can generate, the contours, the slopes, the aspect map, and the thematic layers, of course, can be extracted. The land use, land cover, vegetation cover, urban features, water level information, snow cover. So whatever the thematic layer you want to extract at a higher resolution, you can extract those information. So this is one example with high resolution mapping has been done. So with these images, which is captured at 14 centimeters, 10 centimeters spatial resolution, one can generate a very high resolution topographic information and the topographic map. So this is a map of 1:2000, which could be generated with a spatial resolution of around 15 centimeters. So this is a small area near in Dehradun, where we did this survey. And this is an agriculture field where you have orchards in between a small rural areas, where 1 meter contour interval could be generated. And from this, even the bare earth. Bare earth is minus the terrain features like trees, buildings, what is the actual slope or terrain can be generated, because the density of the points, the height points is so much that I can subtract the surface feature heights and get the bare earth height itself. So this is a bare earth topography in which this is a fault which can be clearly visualized in this bare earth topography, which was not directly visible on the images with the surface features over it. So bare earth topography could be extracted. Here you can see the contour is of 1 meter level, and these are orchards. So different levels of the trees could also, there is a contour generated. So very high level contours can be generated. Slope map could be generated. And the topographic map, as I said, 1:2000 scales, which can be used for cadastral applications. For various other mapping applications, it can be utilized. So this is the slope, and this we compared it with the satellite-based platform. In this area, so maximum slope which you can generate, even the minute slope, small gradations could be mapped with a drone. We could get a slope of 89 degrees and a maximum slope which could be obtained from a space-based platform, the Cartosat data, which is having a spatial resolution of 2.5. We got it as 59 degrees. In a flatter terrain also, with the drones, we could map 8 degrees of variations, whereas with the Cartosat it was 4 degrees. So minute variations, so smaller gradations with the satellite-based platforms were missed out, which could be easily captured with the drone-based platform. We verified it with ground instrumentation. We had the TLS total station. We used these ground instruments to corroborate our results. So it matched better with the drone-based information. and it was totally matching with the GPS and the total station observation. Even TLS, terrestrial laser scanners, also were used to validate these results. And this complete 3D perspective map can be generated. So height of the tree, height of the building, height of the terrain could be extracted with a very high accuracy. So this is for another area where this similar exercise was done in a forested terrain with a, again, moderate hilly terrain, where again this similar exercise was done and a map would be generated. So if you see the remote sensing based applications, if you see for using the drone platform, there are many applications where this can be effectively used. Like as I said, it can be used for generating 2D maps, 3D maps. This is 3D visualization of the terrain. Then extracting various terrain parameters like slope, aspect, contours can be generated. For 3D city modeling, it can be utilized, right? This data can be directly ingested into a GIS database for cadastral level mapping, cadastral information, revenue collection. So various applications, since this provides you with very, very high resolution information. It can also be used effectively for land management, like drainage issues are there, replanting, decision yield estimations, for soil moisture estimations. So these can also be used for these applications. They also have significant role in infrastructure development, monitoring and urban planning, like asset management, as I said, already said, urban cadastre as well as rural cadastres, corridor and power line monitoring, the heritage site monitoring, if there is a damage or any kind of it can be used effectively. In case of mining applications, for volumetric analysis, excavation planning. Then in disasters, in all phases of disasters, they have a very significant role to play, whether we talk about floods, forest fires, earthquakes, for damage assessment, even for search and rescue operations. In forestry and wildlife, for animal counting and other forest-related issues, it can be done. In a marine and coastal applications, it is also effective for mapping of, bars and barriers, for monitoring of the health of navigational channel in a port. You have underwater drones also. So these underwater drones can also be deployed to collect information and map the sea surfaces, subsurfaces in the sea, submarine and communication cables, fisheries, for coastal applications, for mapping the coastal areas. Emergency services, we have seen it has been effectively used in the COVID scenarios. Then drones have been, is a technology which is being increasingly used in the various sectors of agriculture, and government is also promoting the use of drones in two sectors, as I said, disaster management and agriculture. So this is a very emerging area in the agriculture sector where it can help reduce time and increase the efficiency of a farmer. So a lot of drone-based agriculture projects are also undergoing in India. So government is promoting in this areas, also providing, funds for the startup companies to move in this areas. So there are ranges of drones which is there. It has also allowed, which can allow the certification scheme for agricultural drones, which can carry a payload that not only include chemicals or other liquids for spraying in drones. So they can also be applied in case of 2020 when the locust was attacked. Then drones were deployed with the chemical sprays to fight with those locusts. Then, if I talk about the various sectors where drones can be effectively used in agriculture is like soil field analysis. So for efficient field planning, agricultural drones can be used for soil and field analysis, like soil assessment also. They can be used to mount sensors to evaluate moisture content in the soil, terrain conditions, soil conditions, erosion conditions, nutrient content, and the fertility of the soil. It can be also used for crop monitoring, like crop surveillance is the supervision of crop progress from time the seed is sown to the time of harvest. So this includes providing fertilizers at the right time. That is what is called as precision agriculture. checking for the pest attack, and monitoring the effect of weather conditions. So crop surveillance is the only way that a farmer can ensure a timely harvest, especially when dealing with seasonal crops. So any error at this stage can result in a crop failure. He does it manually. He has been doing it manually from his own experience. But crop surveillance with the help of drones can improve his efficiency. So it can help in effective crop surveillance by inspecting the field with these thermal cameras, which can tell you if any plant is infected with disease. And based on their real-time information, farmers can take effective actions to improve the condition of the plant in the field, right? Then plantations also is there. Drones can help in planting trees and crops, which he used to do before, but with this technology, he can save labor and also the fuel. Soon, huge tractors will also be available. Huge drones will be used instead of tractors to emit harmful gases and pollute. Instead of tractors, he can use drones also in this process. Then livestock management, drones can be used to monitor and manage huge livestock, as their sensors have high resolution infrared cameras, which can detect a sick animal and swiftly take actions accordingly. So the impact of drones on precision dairy farming is going to become a new normal, if I can say. Then crop spraying is there. Agriculture drones can be used, as we said, to spray chemicals, as they have reservoirs which can be filled with fertilizers or pesticides. And it can be done efficiently in a very short time as compared to the traditional methods. You can also check on the crop health. So farming is a large-scale activity. Constant survey is required to monitor the health of the soil, the crop. So manually, it will take a lot of time for him. So from drone data sets with infrared data, multispectral data, red edge data, he can easily get this information. And avoid overuse of chemicals. He can know how much, so precision agriculture, which I said, he can exactly know which are the areas, what are the deficiency in terms of nutrients, or where is the infected with disease. So he can apply pesticides, insecticides, or chemical with their appropriate proportions, and over usage of these chemicals or pesticides can be avoided. And he can also monitor the growth. So even government has promoting the use of drones for insurance, crop insurance. So accurate reporting of events which can mitigate economic loss, such as crop health deterioration. So detailed digital record for the contingency plan can be created. Another aspect where it can be used is the geofencing. The thermal cameras installed over drones can easily detect animals or human beings. So drones can guard the fields from external damage caused by animals, especially at night time. They can also be used for irrigation and drainage. So drones equipped with the RGB or thermal infrared camera, so planning and troubleshooting of irrigation systems can be done, and a proper resource management can be achieved with the drone systems. So if you see, so the drones in the agriculture sector have a significant advantage. Security aspect is there. It gives you high efficiency, water saving, then low cost and very easy maintenance. But then there are challenges also for farmers, because then in rural areas where there is no internet connectivity, then there may be a challenge in operating. Weather dependency is there. Then knowledge and skill. So you need a right skilled set person to operate. So an average farmer small farmers will not be effective. It will be effective for farmers which have larger fields, and they can hire people with sufficient expertise to use this. So these are few examples where since the resolution of the data is very high, from the drone data, we can extract the built-up areas, the height of the building, count the number of buildings. Similarly, we can count the number of vegetations, and also the height of the building, the crown size of the height of the trees, and the crown size. So it can be used effectively for an orchard management. You can estimate the amount of yield which will be there. The productivity can be managed. and accessibility to, the road and water body detection, extraction, all can be done with these high resolution data sets. So this is an example where we carried out for extracting the different kind of urban structures and also the health of the vegetation. The mango orchard is there. So you can see the different species of mango which is there, the different ages of the mango with different height, canopy structures, and the total count of trees available in an area. So one can do it for an efficient management of the orchard vegetation in terms of urban area, urban planning, extracting of urban built-up areas, counting the number of trees, the height of the building areas, water body, water feature extractions in different areas. Now, as I said, the role of drone play a very effective role in disasters, where all phases of disasters like pre-disaster, during disaster, and post-disaster. So in pre-disaster, it is prevention, early detection. During disaster, for mitigation, monitoring, relief, and rescue, and post the disaster for damage assessment and recovery operations. Now, drones have a very significant role in the landslide studies and monitoring, which is one of the very common applications for the drone. Where landslide occurs, the first information to be provided is the extent of the area which is affected by the event. So you may not have a satellite pass on that day. When this occurs, one can deploy the drone and collect this information. So the landslide impact extent is analyzed based on, you require a very high resolution elevation information, slope areas. So DM and orthophoto, which will allow major changes to be detected in terms of geomorphological features, also to help in identification, mapping the main features which is there. So landslide recognition, classification, post-event analysis, even preventive actions can be done. If you have a good model of this area, one can simulate and see if the landslide occurs in this area and what will be the rate and flow of the debris and what are the areas which will be affected. So a pre-warning can be issued. So landslide susceptibility and hazard assessment can be done. So this is an example where a landslide occurred and high resolution drone images were captured to assess the damage. Similarly, we also have done a small exercise in the Balialana area of the Nainital region, which is a landslide prone area. We took these photographs, if you see, in this very bad condition, foggy conditions, the cloudy conditions, but we could fly much below it and collect this data set. So the data is not affected by the cloud conditions. So we could fly and then assess the entire landslide area, map this landslide area, generated a very high resolution contour information, slope information, and this could be used to, prevent or create structures so as to, for further actions to restrict this landslide zone from further creating damage to the people living in this area. So this was usually used, can be used to assess which are the areas, once this landslides with this rate, which are the areas will be impacted. So you can give an early warning to the people to vacate these places and further, prevent from, create structures here, erect structures so that you can prevent further damages in this area. So this you can see, it provides very, very high resolution information. The minute variations in this area can be easily captured. So topographical variations can be easily captured in this area. See, this is the built-up area which is there. So small, whatever objects or small features were there, even a cot which is placed on the house of any house or the roof of the house can be easily captured. This is another example which we said, which spatial variation of a simulated flow height and velocity of the landslide area closer to it. It's a dormant landslide, but then we could collect a very high resolution data by flying along the slope of the hill, and then from here generated a very high resolution elevation information of an order of 20 centimeters and an ortho image. Then we did a modeling, ramps modeling, in which it was estimated if there is a landslide, and then along the slope, what will be the speed, the flow, height, and the velocity which it will flow, and which are the areas which will be impacted if it flies. You can do a simulation that what will happen at different speed, height and flow, velocity, what it will be there, and maximum area of debris where it will reach, and what are the areas where it will get, or any settlements are there, it will be impacted. So you can give an early warning system. So one can do a preventive action before in these cases. So another area where it will be used will be for the earthquake damage assessment. So post the earthquake happens, how much for search and rescue operations it has been effectively used in the Nepal earthquake, where drones were deployed to search and rescue people in these areas, because there were many locations where it was difficult to move around. So drones were deployed in those areas, and they entered on those places and tried to search for people, and accordingly rescue operations were done. Then later on, these images were also used to assess the damages to the buildings. So as I said, the main advantages of this was the availability, ease of deploying it instantly wherever. The moment this earthquake happened, a few hours of it, the drones were deployed for search and rescue operations. Similarly, in the Uttarakhand disasters, which was happened recently, Chamoli flood disaster, where again drones were deployed to rescue people. So these can be effectively used for search and rescue operations. This is a small experiment which was done for to assess the damages which from the drone-based platform, and how satellite-based observation becomes a limitation. Now, this is old, monument in Myanmar. It's a Sulamani temple in Bagan, Myanmar, which was damaged due to a violent earthquake of order of 6.8, which hit on the 24th of August 2016, which significantly damaged this 14th century archaeological site. And if you see this, this is a satellite image post the damage happened. Now, because as I said initially, that the acquisition geometry as well as the illumination geometry, now the sun is from this side, so this area where the damage occurred was in the shadow region. So from the satellite-based platform, though we have an image post-disaster, but the area where the damage occurred was in the shadowed region. So no information could be extracted from this. So if drone has an ability where you can fly along all directions, from all directions it can collect the data. So this is a drone-based image where the complete picture was collected and processed, and the damage was assessed, the volume, the debris, the volume of the debris which was generated was also easily measured. So the UAV can collect multi-directional view, which enables clear visualization of both damage and the debris. Damage assessment was more accurately done as compared to the satellite-based, because satellite-based the observations were missing in the damaged area, right? So with high accuracy, the damage assessment was done using a drone-based platform. Drones can be effectively, has been effectively used for again search and rescue, and for providing assistance in the flood affected areas. So in Japan as well as in India also, it has been effectively used in Kerala, Chennai floods, and Karnataka and other places. Drones have been deployed for both these operations, and also for assessing the post-disaster damages. Then for forest fire detection and management, again, drones can play a significant role, because manually it can reach the sensors, the thermal sensors can tell you the mouth of the fire. So it can be mounted on them. They can exactly tell you where the fire exists, so that accordingly actions can be taken to extinguish the fires. Even drones can be deployed with proper these sprays, and they can reach through those areas quickly and faster to extinguish the fires in those regions. So forest fire detection and complete management activities can be effectively done with the drone-based platforms. Drones can also be used in disaster for communication applications. Right, so wireless-based sensors where communication has been completely destroyed, drone can act as intermediate, controller or relayer, and they can communicate or provide communication in areas where communication has been totally been destroyed. Right, so these are few examples of drones used in agriculture sector. I've already highlighted the areas where drones can be effectively used in agriculture. So this is, if you can see, the infected crop. So the size of the crop is very small. So even from when you collect from satellite platform, we probably will miss out because of the spatial resolution. The damages cannot be effectively mapped. These crop disease cannot be mapped, but since it provides you 1 centimeter level of resolution, so one can easily get the size of these crop is much smaller because of the resolution you see, but from satellite-based platform, they may be missed out. So these are small crops can be easily where it has been infested with the brown plant hopper insects, so they can be easily measured. Then here also productivity can be mapped. So unproductive tea bushes, where it is there in a tea plantation area, wherever there is a nitrogen deficiency in a paddy field, accordingly he can take action and provide a necessary nutrient in this small patch. So efficient management of the crop can be done. So this is a disease and pest infested in trees, banana plantations. So he can do complete mapping and monitoring of the crop areas for his own better productivity. Another example is in Maharashtra, where monitoring wine grapes in India, in Maharashtra, is also done with drone. So he can know where the harvest would be first and where the harvest. So depending on the growth stages, continuous monitoring, he can know where to harvest first and which are the crops or the areas where he needs to do it at a later stage. Then even in mine measurement, we can go for planned and efficient and safer mining operations, get the volumetric analysis, quickly chalk out the pits and mine reclamation plans can also be effectively planned. And drones can also be used to collect other types of environmental data of public health relevance, like environmental factors such as radiation and air pollution, which vary spatially with important consequences for human health. So monitoring equipment can be fitted on these drones to measure levels of environmental toxins and pollutants, mapping health infrastructure such as water and sanitation systems and locations of health facilities. If you talk about infectious disease epidemiology, UAVs we can provide a new alternative to collect detailed georeference information on environmental and other spatial variables which influence the transmission of infectious disease. So it can be used for various areas in various domains where it can be effectively used. So, but it cannot replace a satellite-based technology. It can be supplemented with satellite or space-based observations. So wherever there are gaps or in the satellite-based observations, drones can effectively come into picture and provide you this missing operations, the missing information which is there. Then drones, as we have seen, has been effectively used in the pandemic time, where drones are used into prevent the spread of the coronavirus, especially in countries like Australia. Pandemic drones, which used temperature sensors and computer vision to identify symptoms of infectious respiratory disease. They are capable of remotely monitoring the temperature, public spaces. It can collect thermal sensor from using thermal sensors, the information, and highlight where anomalies are there, where the temperatures are higher. So monitor fever in a large gathering using thermal images, monitor the congregation at religious places, deal with contaminated and crowd places, maintaining of social distances, announcements. So all drones have been effectively used. They have been used for spraying this sterilizing the spaces by spraying the disinfectants. Then many countries have used this effectively. Then they're also using in food delivery by drones. Even surveillance drones are there for quarantine, for emergency medically delivery by drones. So they have they've been effectively used to transport samples from hospitals to laboratories, deliver essential protective equipments, and medical devices to remote places, patients in remote places. So if you conclude, drones provide an ultra-high spatial resolution data, which can be effectively utilized for mapping at local scales. You can have 5 centimeters, 1 centimeter level data sets. You can get a digital surface model, ortho images, digital elevation model, which can be with a higher accuracy of 5 centimeter or better, vertical accuracy of 10 centimeter or better. They can fly at any altitude and in a difficult terrain. They have an ability to reach remote and inaccessible areas. They can acquire images at any time and with different angles. They're capable to mount sensors as per the need. Small UAVs are a powerful tool for disaster risk assessment, monitoring, response, agriculture, urban infrastructure mapping, and they are cost effective. So they have their own limitations in terms of the rules and regulations which are there. So in our cases, the rules are monitored by the DGCA, the Directorate of Civil Aviation. There is a website called Digital Sky, platform called Digital Sky, where you need to register your drones. When you buy a drone, they have to be proper registered. It is to be with certain norms. You have to follow those norms. And even to fly, though they have made 3 categories of zonations, the green zone, red zone, and a yellow zone. So for a green zone, generally they are agricultural areas. Few areas have been earmarked by the DGCA. In those areas, just by intimating the local authorities, you can fly, but they are earmarked zones are basically the agricultural zones where there are no habitations, but still you need to inform the local authorities before you fly. But for the yellow and the red zones, anyway, you cannot collect the data. For the yellow zones, it has to be appropriately taken permissions from the respective authorities, from the DGCA, and then accordingly you can collect this, you can fly. So you can register yourself, or if you buy a drone from this DGCA website that is known as Digital Sky. Then another challenge with the drone is the size and the volume of the data which it consists. So a single drone flight can collect over 70, maybe 100 terabytes of data. So you need a complex processing, sophisticated high processing storage facility, processing facility. So you can say drones follow under the category of big data. So they require, optimization measures to manage these data sets. So to process, store, and, process and store those data sets or manage data sets, you need effective systems, good systems which can allow you. So you have, and also specialized softwares are required to process this software. So few softwares are available as open source with certain limitations, but commercially off-the-shelf softwares are there which you can utilize to process these drone data sets. So with this, I would like to conclude. If there are any questions, I would answer those questions if you have any doubts. So I try to give you an overview about this technology, not going much into the detail. If you have any kind of questions, you are free to